Okay, I have 3 years, 1980 and 1998 and 2002, and the question I want to ask is there a difference in the means between these 3 years? And since I have more than 2, this is a good example of where I'd want to use an ANOVA. And so my null hypothesis is going to be that the mean 1 equals mean 2 equals mean 3. In other words, all 3 of the years are approximately the same temperature. And then my alternative is going to be that at least 1 is different. Okay? Now to do this, I need the actual data. I'm going to go up to Data, Data Analysis, and I'm going to go to ANOVA single factor, and I'm going to put in my input range. So B3 through D34. Okay, and I want to put labels in front row. I'm going to test at 0.05, but you could change this if you want. I'm going to have it put the output right here on the same page over here in M. And here is my ANOVA. And what I care about is this value right here. This is my p-value, and if this is less than 0.05, and it is, then I can reject my null and say that at least 1 mean is different. Now this does not tell me which one is different. Now I can look at this and I can guess it. Oh hey, 2002 seems much higher, but I can't prove that from here. I would have to move on and I would have to do a post hoc test like the Tukey to be able to prove that or do something different. All this tells me is at least 1 is different, but that tells me that there is a difference between these 3 years, whereas if I'd failed to reject, it would tell me that the 3 years were approximately the same. And so for a ANOVA, that's literally all I have to do. Excel will do all the work for you, and you just have to analyze this p-value right here and tell yourself, hey, is this less than the significance level I picked? Make sure to tell me what significance level you are testing it at and what your conclusion is. So in this conclusion, I would reject the null, and I would be able to say that at least one of these means is different. But as I said, I can't say which one unless I do a further test.